Can you hear me in the back? Okay, sorry. My name is Bill Riley. This is Tony Licio and Edward Kasperzak. We're the chief design judges for this May Formula SAE event. So we'll be starting the design feedback session now. We're going to start with a recap of the top 3 finishers, of which there's 4 cars because of a tie. We'll go through that. Then we're going to go into some general design considerations, which Tony will talk us through. And then Edward's going to speak to testing and some of the design submission documents. So with that, we'll go ahead and get started. At the very end, we'll do a question and answer, but you can ask questions as we go. We'll just give you a dedicated time at the end if anything else comes up. So overall considerations, we put this together by kind of looking at all the cars over the last few days, some things that stuck out to us. So this is not just about the design finalists, but points we really wanted to make. Vehicle architecture. So one of our final design questions, as well as a topic we touched on in preliminary design, was how did you lay out the overall car? Like if you imagine there's a chief engineer element, even if it's one person or more than one person, how did they make cross multi-system, multidisciplinary decisions, such as powertrain, chassis, weight distribution, aero? Making sure you have a rigorous engineering process that's not kind of like gut feel or looking at the grid was an aspect we asked about and felt like generally across the board everybody could work on to improve. Vehicle mass creep. I was saying that 450 is the new 400 and it really shouldn't be. So make sure you're looking at mass. Mass begets mass. We'll talk about that more later. And be really, really aggressive on eliminating weight and making your vehicle light. We're one of the few series that doesn't have a minimum weight, and we really value having the cars be light for many reasons. Understand other options. So sometimes your choice is made up for you. If you have an engine, 3 engines of a certain design, and you really don't want to switch because of overall team bandwidth, dyno, access, funds. There's many reasons we know why you need to run a certain configuration, but that should not limit your engineering assessment of that option. So for example, if you have a 4-cylinder engine you've always had, we would like to see how a single-cylinder engine might have changed your vehicle design, or how many points could you have picked up with the lighter engine, or how many points better were you because of the 4-cylinder. Another example is aero. Just because you don't have wings on the car doesn't mean you shouldn't have looked at them to understand the sensitivity to that decision to leave wings off the car. And this is, if you think about design as coming to talk to the design judges, we have a bucket of points. We want to give you all of them, but you need to address some of these areas. So if you decide on week 3 that you can't do wings because you don't have CFD or a wind tunnel or something like that, which I don't think any one of those elements is a reason not to, you don't need to give up on the aero points. You should still look at analytically, look at lap sim, evaluate these options. This is a really important part because when you don't do any work in it, it really limits our ability to sort of give you those points from our bucket. Load paths, they're fundamental. Also, we saw a lot of people considering the basic load cases, but in final design, we were asking for things like when the brakes are locked up and you had been rolling backwards and then you lock the brakes, it would be nice not to buckle the A-arms in that case, for example, because you end the day. So this is just make sure you're considering the basics and a couple of the off-nominal contingency cases that could take you out of endurance. And lastly, I wanted to say from all of us, chief design judges and design judges, we thought this was one of the best years ever for being open to our feedback, having a discussion and dialogue with us and talking us through things. We really appreciated it. We really valued it. I think a lot of us are motivated to go back and over the next few weeks and months try to work on content and helping put more information out there or directing you to what's out there already to kind of help everybody rebuild after the COVID. Because we know there was a loss of continuity of information transfer from students, upper level students to rising students. So we want to try to help bridge that gap and also just say thanks for being so open. So let's give a round of applause to tied for 3rd place, Purdue University. Purdue came in at about 389 pounds with a 54% front weight distribution. We weren't really able to get at the design rationale for the 54%. So we're not like endorsing any of these numbers, but this is where the car ended up. So that's some feedback for them to sort of justify some of these outcomes. And also for the entire grid to make sure you're watching your mass growth in your CG, where your CG ends up. That's part of the engineering process I was talking about. They were running a single-cylinder Yamaha on gasoline with the 10-inch LC0 Hoosiers with a space frame. and front and rear wings and under tray. Some of the notes we took from the final design was they had a well-sealed radiator duct and good consideration of the airflow. There's a lot of cars here I noticed that have kind of the radiator out in space that relies on the fan without even sort of a nice entry condition or duct work. And also remember, if your radiator's in the middle of a huge duct, the air's going to want to bypass it, not flow through the radiator. So really getting good sealing and driving the air where you want it to do actual heat transfer is something to watch out for. In terms of aero, they understood the theory and the equations and had excellent build quality. We thought the next step would be to consider developing around different ride heights, so they're sort of focused on one ride height rather than the range that you might expect to get. The brakes were well integrated with the suspension components and had good knowledge of the mechanical elements. Again, the next step there might be to work on the thermal modeling of the brake system. The ergo judges felt like the adjustable pedals were really good. The seat had some points that dug in, so you might want to take a look at the cars after the feedback session outside. We've brought them there for everyone to review. Good understanding of chassis stiffness on steady state handling, and good structural analysis of the suspension, both in the design and had excellent workmanship. So a really nice looking car. Congratulations to Purdue. And the tied for third place is Florida. So congratulations to Florida. Florida came in at 442 pounds with a 48% front weight distribution, running a 4-cylinder on gasoline, again with the 10-inch Hoosier tire in the R20. They had a hybrid monocoque, meaning a rear space frame and a front tub, and they had front and rear wings and under tray. When we were talking to them, we noted they had a good understanding and a good intuition for loads going through the chassis. The ergo feedback, the drivers of a large range of sizes felt the pedals had a good range of adjustability. There was a little bit of desire for more hip and shoulder support. They had a good understanding of composites, the laminate failure modes, which is very important for designing composite parts. There's a lot of different ways composites can fail: peel, shear, interlaminar shear, all these different failure modes. And it's important to think about them and how they impact the car design. Suspensions showed good use of simulation tools, good use of finite element analysis. Just make sure to understand how the tools work and how to get the most out of them. It's very easy to get wrong answers from all these tools. And we need to get meaningful answers, because obviously there's always a difference between test and analysis. And we want to see you compare with data, do model correlation, and try to get results that help drive the design and make it better. They had a good mid-year design reviews that they used as a project management tool to gate certain milestones and progress along the way. Because as you all know, that Formula SAE is also a project management exercise. Just getting here with a car, you have a huge amount of respect and support from all the design judges, because we know how much work it is. And lastly, they had solid documentation of test sessions. So again, congratulations to Florida for their third place in design finish. And in second place, we have Berlin. So Berlin came in at 387 pounds with a 48% weight distribution, running the KTM single cylinder on E85. They also had a 10-inch wheel with the LC0 Hoosier and a space frame. Also, I will say that looking at the cars this year, there was a nice mix of tubs and space frames. I think we, as design judges, appreciate both, and there's no right answer for sure. So it's nice to see a mix up here in the top 3 design cars. And they had front and rear wings and under tray, as you can observe from the picture. We felt like they had perhaps the best and most rigorous engineering process around vehicle architecture decisions that incorporated points modeling, lap simulation, vehicle configuration. They understood how making more downforce would add mass to the wings. They understood weight distribution and all the different elements that go into making a cohesive car, rather than one that's designed sort of by committee and at each of the discipline. So that was really impressive. They had a professional grade documentation and systems approach for the vehicle configuration. We think it would benefit from further extensions in some of the subsystems, but it was really great at a high level. Powertrain, they understood the points impact of different air-fuel ratios, for example, because obviously there's a trade-off between power and fuel economy. They had the best understanding of load paths and the ability to discuss less obvious ones, such as the car sliding backwards with the wheels locked, which you might get, obviously not nominally, but in a contingency case. The Aero was well-developed package for ride height and speeds. We thought the next step would have benefited from having more data at hand rather than speaking to it generally. Ergo, folks felt it was a comfortable seat. It would better fit from better longitudinal support. I will add that for Ergo this year, we had both someone representative of a 95th percentile male and someone representative of the 5th percentile female. So we really are trying to check a range of demographics of folks who would be purchasing these cars, and also that's what's called out in the rules. The suspension had excellent build quality, and it would benefit from more structural analysis. And lastly, it was self-designed engine controller, but the thing in addition to that was the clarity around the code and the code management we thought was very excellent and would benefit them in years to come, not just this year. So let's give Berlin another round of applause for their second place finish in design. All right, and our design winner for this year is Illinois in first place. And Illinois came in at 424 pounds with a 49% front weight distribution, running a 4-cylinder on gasoline, also with 10-inch wheels with the LC0 Hoosier compound, running a space frame with front rear wings and a partial under tray. The Aero reviewers felt that they had an excellent trade study. Operating conditions were weighted, downforce versus mass, these sort of elements. The next step would be to better integrate the Aero in the spring selection. Brakes, they had a great simulation of brake temps. They had relevant dyno testing and coast down data from the vehicle. And the next step there would be to work on improving the analysis to test correlation. And that really shows that we're looking for all 4 of these elements that we call out in the scoring sheet, which is the design, the analysis, the testing, and the validation, and tying it all back together. They had an excellent grasp of vehicle dynamics, systems, fundamentals. They could reason through our questions. Even if not immediately known, they could reason through it, use their intuition and their base knowledge to talk us through it. The next step there was to develop more knowledge around transient conditions rather than the steady state. The project management, they were great at tracking the as-built versus the as-designed. So what we mean there is what was the mass target, what was the center of gravity target, the weight distribution, the CG height, like what are the things you're trying to accomplish? One way we measure, we sort of judge that is the difference between the design spec sheet that you submit and the car that you present to us. So that's what we mean by as designed or the as built. We'll talk about that a bit more later. And electrical, they had a good understanding of failure modes and inclusion in the design. So for example, derating the electrical systems for longevity and success there, even when they had a low battery. So let's again congratulate Illinois on their first place design finish. All right, and with that, Tony Licio is going to talk through some design considerations and general design feedback.
One of the aspects that we kind of acknowledged as the competition started is the fact that, you know, in general, we've got a large number of teams and participants in teams that really, you know, this is their first competition. You know, typically it's, I don't know, well over half the people, you know, have been in a competition before, and that's just simply not the case this year. And another piece of that is that, you know, as teams are able to regularly attend competitions, you know, there is an ability to see other cars on a somewhat regular basis. And given that, you know, for most of you, it's been a few years since your school and your teams have been able to actually, you know, attend a competition. And you know, so the thought was to kind of go back maybe half a step, you know, and kind of talk through some of the more fundamental considerations. As I'm assuming that, you know, for many of you, your eyes have been opened up a little bit as to what the potentials are for an SAE team. You know, working on within the same team, even with, you know, teams progressing from year to year, you know, your vision was probably somewhat narrow just, you know, by the lack of exposure to other vehicles, you know, and now hopefully, you know, some of these thoughts, as well as being able to actually see various different teams competing, it'll kind of help open your world up a little bit to some different things. So general design process. First off, like, what should the starting? Actually, I will note that these cars, the photos in here are a few years old. So if you're trying to figure, well, what car was that? It might have been as much of a decade or so ago that the car was actually here at MIS. But anyways, starting point, rules, tires, scores, lessons learned. You want to be before you really kind of get up and going too fast and hard designing next year's car. You want to stop and think through just what should our starting point be? What should be the baseline or the foundational stuff of which we're progressing through. On a per event basis, what are your goals? There's probably going to be some design compromises that you're going to make for one event to another. If you want to absolutely win, the acceleration event, and by far that is your biggest want to do, or your goal, you're probably going to make some very different design decisions than if you're trying to win the competition outright. So again, it's important to think through some of these things. Once you've got some high level goals, what specs is it going to what vehicle level systems specifications is it going to take to actually hit those goals? You basically start high and start working your way down, from the high level goals to smaller ones. Obviously, as you have your system level specs, then you start breaking those down to the vehicle level or to the system levels, and all the way down to the component. Ideally, the big picture should be overriding any other design decision. We see a number of teams where they'll break up into powertrain team, suspension team, what have you, aero team, and the powertrain team is off kind of doing their own thing. They're doing a lot of really good work, but maybe they're not. There's just not a lot of integration with the rest of the the other subsystem teams, and so you develop some great systems individually that don't play well nicely when they're all come together. Or one system hurts another system, so the gains you may have found you kind of neutralize, kind of a thing. So it's very, very important to be always looking at the big picture, the high level goals, and making sure that everything is feeding in towards meeting those. One of the big things here, and it's been mentioned a couple times already, is the vehicle, mass and center of gravity. What your mass is and where that mass is, as well as moments of inertia. Those really dictate the vehicle dynamics of your car. And you can tweak suspension parameters. You can stiffen the front and stiffen the rear. Do things. You can do things to improve balance, but the fundamentals are pretty much defined. The base physics are defined by where is the mass, and how much is the mass and where is it, I guess. Moving through again, kind of a system level thought. Think about every component, its interactions with the other systems. Weight distribution, center of gravity. Again, it's more than just a specification to write down on a sheet. It's a very, very critical target. And it's going to again define the behavior of your vehicle. And then again, as you continue to go through, you don't just set your numbers and just start running. You need to be iterating through. Ideally, you're going to be having learnings as you build and you develop your car, as you perform simulations. You want to, as those learnings come in, you want to cycle through and iterate, through the overall decisions that you placed early on to make sure that those are still the right decisions. One of the, we try to hold teams accountable to like what they put down in the spec sheet and their design documents, that kind of a thing, through design judging. But if a team can come to us and something might be very, very different from what they told us initially, but if they designed to that different, basically we did some testing, we had a learning, and that learning drove us to changing the design slightly, and that's why the design we have in the tent is different than the design that we submitted, on paper months before. That's going to work to your advantage. I mean, that shows that you're using the process to make your car better, make your team better, and that's exactly what we're after. Let's see. High level considerations. The old keep it simple, stupid, versus going all in high tech. Teams try to assess your overall team resources. Do you have the time to truly do what it takes to do a complex and potentially higher performing car, or would you be better off building a simpler car, making sure you can get it done, and having time to develop it to its best of its potentials? Tire data. Want to mention the the tire test consortium. It's got to be one of the, well, I think bar none, it is the best opportunity, I think, in the world for anybody to have access to high quality tire data. It's really $500 is basically a long-term. It's a pretty long-term membership, at least for version 1. There might be a tire test consortium version 2 to try to figure out what the next step should be. But man, there's just a wealth of data out there. And then all your fellow Formula SAE colleagues out there talking about how to use the data, working through different scenarios. It's definitely it's a really useful community, and it's just a great opportunity for you to learn, not only to acquire the basic data, but then to have a resource leaning on each other to learn how to utilize it. Data acquisition, obviously it's a great engineering tool, but it is also a tremendous driver training tool. There's no question that it is not easy to drive most of these cars at their true limit. To drive fast in them and feel like you're going fast, piece of cake. But to actually get everything out of them, it takes quite a bit of skill. And so make sure that you're using your data not only to get little tidbits here and there about the car performance, but also be evaluating your drivers and developing your drivers with them as well. Mass versus stiffness. Obviously, we want to be as lightweight as possible, but compliance is a huge factor as well. In particular, the suspension side of the house. So make sure that you're looking at things from a holistic standpoint. Fuels, some decisions to be made there. Tiny little parts. Obviously we harp pretty heavy and hard on vehicle mass, and it is important. But at the same point, you also have to make sure that you've got adequate reliability. Again, especially if you're thinking, if you're a smaller team, fewer resources, you need to be able to build the car and have it work. You can't be rebuilding every single part, because you have minor failures, that kind of thing. So, set your safety factors, understanding the risk that you're undertaking. If you're a very, very large team, lots of resources, you can maybe go a little lighter on the safety factors and risk, maybe breaking apart in development. Make sure you've got the time to develop it and make sure that, you've got it sorted out before you come here. But again, if you're a team that's new, small, maybe you go a little bit heavier just to make sure that you will not have some of those failures that you don't have time to recover from. Materials, lots of really cool carbon bits on cars. Just, make sure you're making the right call. Don't make it out of carbon just because carbon's cool. Make sure that it's actually the right material. As we're going through the designs and talking to the teams about, their choices, we want to have a sound reason as to why they selected the material process that they did to build their car. So make sure you're not just doing things because it's cool or doing things because you see other teams doing it. Make sure that you have a solid engineering reason and rationale for it. Modeling, analysis, and physical testing. Again, it's easy to make models. All models are wrong. Some are useful. Some people say. Make sure that you're taking the time to do some sort of physical validation. Try to validate your models early so that you can have some confidence that in their accuracy and their applicability. And then you can iterate, and then at the end you want to be finishing things up with additional validation to again correlate the model, kind of close the loop, and make sure that what you have is you have what you think you have. Design complexity, again, this is another example of the KISS principle versus doing something simple. Both of these suspensions do the exact same thing. The one on the left there is the kinetic suspension. It does some really cool stuff. It has some advantages. But again, if you're a small team, limited resources, and maybe limited budgets or what have you, there's no question that that you're making a big trade-off if you try to do the hard to do complex thing. Both, if well supported in design, you can get very similar points with a simple car if the engineering is well done. We're not trying to score based on number of cool bits you've got in your car. We're not scoring based on complexity. If anything, sometimes if it's complex but without a good reason, we're probably going to beat you up over it. Because again, we want to see valid reasons for every single design decision that you make. Aerodynamics, obviously a very significant portion of the cars here have aerodynamics. We like to see aerodynamics. They can be very, very effective. But again, it should be a design decision that your teams are making, not just arbitrarily. You want to be able to support the design decisions. And again, as it was mentioned earlier, it's okay if your car doesn't have wings, but we still expect you to know you know, what did you give up by not putting wings on the car? What were the trade-offs? And just, again, support the decisions that you made. Composites, also another thing that was mentioned. Carbon tubs are cool. There's no question. They are cool. But, you know, space frames have their advantages too. And it was very interesting to see the mix of cars, and really even the mix of cars at the top of the field, you know, on the track and in design. You know, you don't have to have a carbon tub to do well in the design. Are there advantages of it? There are. Are there disadvantages? There are. So just, you know, make sure you, again, before you just try to do what you think, before you try to do and provide the content that you think we want to see, really what we want to see is good engineering, sound decisions, lots of logic-based, test-based decisions. So make sure that, you know, that when you're making your decisions, you're doing it on vehicle performance and what you want your vehicle to be, not what you think we want to see. Okay, these are kind of just some, I call them qualitative rules to keep in mind. These are the kinds of things that I want you to be, you know, thinking through kind of regularly as you're going through the design, as you're building the car, as you're testing. You know, I mean, it's pretty simple to say, if it looks right, it kind of usually is. You know, the corollary to that, and this is, you know, to be honest, often how, you know, us design judges find things we're like, you know, that we're going to burrow in on. It's like, that doesn't look right. And we burrow in and we find out that it was an afterthought, or, you know, maybe it wasn't well supported or something along that lines. So make sure that, you know, just like we look at the car and looking for things that do or don't look right, make sure you're doing the same. Load paths, obviously, we highly value good load paths. You know, it's at this stage, with the amount of flexibility and you know that you have with your designs, there's almost, you know, there's very little excuse for poor load paths. You know, they impact part stiffness, they impact part strength. You know, they're just the sources of compliance. You know, there's just, and you've got complete flexibility to put things where you want. So it's important to us. Simplicity, the best part's no part. Obviously, it's going to weigh nothing. It can't break. Doesn't take you any time to development. You don't have to spend time building it. So again, make sure that you know, as you're adding complexity, that there's a reward there, that there's a benefit, that there's a valuable trade-off. Systems engineering, know it, love it, live it. There's a lot of thoughts that, you know, that the way we judge, that we really don't highly value the systems level aspect, you know, because we'll have like the engine person talking to the engine person, the aero person talking to the aero person. While we do break things up in order to have the discussions, just as a matter of just, you know, practicality during design, all of the judges do highly value the integration. So the better you can define your systems and how they interact with the rest of the vehicle, and then, you know, provide, again, a vehicle level performance, that's important to us. So we ask you to be thinking about those things as well. Engines, spark is one thing that's often overlooked. You know, it's a pretty decent knob. It's something, if you get it right, it can yield some decent rewards. If you get it wrong, it can really hurt you. So make sure you're sparking your engine right. Mass, again, mass begets mass. There is no minimum weight. Obviously, you want to be as light as possible, but be reliable. We know it's kind of a tricky balance to find. But, you know, that's why we're all in engineering school, right? Is to learn how to make these trades and make, you know, do the right calculations, the right simulations and testing and whatnot. All right. Does the car, you know, again, more things to be asking kind of regularly. Does the car look like it was designed with a systems focus? You know, do parts look like afterthoughts? Often, you know, we see like, you know, coolant bottles or, you know, various brackets, and it's pretty clear that that part was not designed there from day one. Like nobody would logically design the thing that way early on. So make sure that, you know, as you're designing your cars, you've got every possible thing that you know designed in and accounted for. You know, and mistakes are going to be made. You're going to have to adapt things, you know, as you go. But make sure that you really put a lot of effort into having a plan for every part. Don't just think, well, we'll figure that out down the road. It's like, no, you need to be factoring everything in early. You may not have to do fully detailed design, but at least package, protect, and do some of the things that you need to kind of rough things in. You know, is the packaging tidy and look planned? Are things such as wiring, you know, exposed or neatly routed in looms? One of the things I personally found rather offensive about a number of the cars is just how sloppy some of the wiring is. I mean, literally, if, you know, in many cases, if somebody just took, I don't know, an hour or two with some tape, some zip ties, You know, they could have made the thing look worlds better than it did. You know, and this is just like little attention to detail things. Do they always make your car faster? Okay, fine. Maybe not, but there's a decent chance that they might make your car more reliable. You know, wires moving around, wires running across poor edges, you know, the jostling. I mean, there's all kinds of things that you know that can result in failures that are just completely avoidable. Not to mention the fact that it just tidies things up and, you know, it just gives the car a much more professional appearance. I kind of mentioned like the wires crossing over sharp edges. Similar kind of things, you know, are things such as brake lines on the front or the leading or trailing edge of the control arm. If you don't have to hit a cone with a brake line, why do it? You know, just put the line on the other side, you know, and just, you know, eliminate some of those potential failure modes. Is the car on track to mass, CG, packaging expectations? You know, as parts come in, as you machine parts, you know, you ought to have a fish scale or some other, you know, be weighing things as they're being built. Make sure that you are on track. You know, because say you get a part that comes in, you know, half a kilogram heavy. Okay, the half a kilogram heavy, what does that do to my weight distribution? Should I be trying to, you know, resolve that somehow? Is there something else I can move to fix it? You know, I just took us off target. How do I get us back on target? You know, make sure you're tracking these things as you're building your car, not just you design it, you build a car, you get to the end, and it's like, well, where do we end up? It's like, there should be no surprises there. You should be knowing what your trajectory is and kind of tracking that trajectory as you're building the car. Tuning, again, one of the, you know, obviously these cars are going to be very sensitive. Hopefully they're very sensitive to tuning tweaks, you know, and that you can, you know, benefit from that. Make sure that you're designing in adjustability, tunability, you know, and that when you make a change, you're not changing 4 things at once by making one change. Make sure you can make discrete adjustments, you know, so you can target your adjustments on what you're looking to actually impact. A couple packaging examples here. Again, these are old pictures, so you know, none of your cars should be right here. But again, it's just stuff like, it just kind of looks, you know, kind of sloppy. You know, some of the things might be in harm's way. A lot of them are probably okay, but again, why take the chance? And then you can contrast that with this. Like some of these cars, is like you literally have to like, is there even wiring to those injectors? Like you have to like look for some of those features because they're so well integrated and kind of just tucked away. You know, the comment here, you know, the hard part is to make it look easy. It's pretty easy to make it look hard. You know, you can easily make something look way more complex, but really what we're looking for is the car that we look at. It's like, wow, it's just so simple. There's nothing to it. And then as we dig deeper, we actually find the little nuanced, you know, little details that made it that way. Again, being tidy with the details. Lots of stuff. You know, again, the details are one of the things that really kind of a number of the teams here, more so than previous years, I think kind of missed. And I think a lot of it had to do with, you know, again, newer people coming in, less knowledge passed down from team to team, less experience with the cars, these kinds of things. But I do believe it, you know, it's important. Extra threads. We saw a number of cases where it's like, man, that bolt should have been like, well, there's one case where the bolts probably should have been about 1.5 inches shorter. But you know, just do it. You know, I'm not referring to the wheel studs. I don't know. I play with wheel spacers, so there might be some justification for that specific example. But you know, like suspension, you know, control arm bolt should never be like an extra 2 inches long. You know, that's just kind of silly. Wing mounts. Again, you want them simple. You want them strong. You want them stiff. Pretty much self-explanatory. You know, ultimately, you want it to behave like a structure. You know, treat it like the structure that it is. There's a number of wing mounts that are pretty floppy, pretty flimsy. You know, and if you actually are producing some downforce, the wing's going to deflect out of the way and not be producing what you want, or it's not going to be behaving in the manner that you designed it. All right. With that, I will hand it over to Edward.
Yeah, thank you, Tony. Okay, so we're going to talk about testing and submissions. So, when you first saw a Formula SAE car, what was the first thing you thought of after the, whoa, that's cool? I mean, you probably thought things like, how fast does it go? I want to see this run. You know, just there was some excitement about actually seeing it do what it is built and designed to do, right? Drive, perform, and honestly, when you go testing, there's probably still that same kind of excitement. That does not go away. Doesn't matter if you're your age, our age. You know, it's always exciting to see a car doing what it's meant to do. But you have to not lose sight of the fact that testing is always a limited opportunity. Okay, you cannot go there and just bomb around a parking lot or a test track and have a great time and not accomplish something when you're doing it. And so even though, yes, it's exciting and it's thrilling and it's if you're driving especially, that's awesome. We want to approach this with an engineering mind and an engineering outlook so that you can actually use your testing time to support your engineering goals, to develop a better car, to, in the end, have a better performing car, score better at competition. So it's not unusual to have a lack of testing discipline. When you are going to go to a test, first of all, you should have a setup sheet for your car. This is essential for knowing where you're starting, what your settings are, what your baseline is. You know, list things on there like what are the corner weights. If you're not weighing your car before you go testing every single time, setting your corner weights, you're bound to just lead yourself down a path that's confusing because you will not have the same starting point every time. So, you know your corner weights, mark them down. What is your toe setting, your other suspension settings? If you have wings on the car, what are your wing angles? The list goes on and on and on. Keep working on that. Iterate your setup sheet because if you're doing it properly, you're going to want to refer back to this. You're going to look back and say, oh, I never wrote down what that was. So it gets added to the sheet the next time. Make sure you have a setup sheet every single time. Also, have a packing list. Most people do not test right near their shop. If you do, you're fortunate. But even if you are right next to your shop, you don't want to keep running back in for something. Make sure you have all the things you need, all the tools you need, any spares for things that are likely to break that you have a spare for, just plain old safety stuff, hydration, etc. And that's also a list that can keep iterating through time. Keep working on that list. When you run the car, again, don't just bomb around the test track. Have a plan. Why are you driving the car this time out? And the driver needs to be very clear about this. Okay? What is the intention? What are you trying to measure? What data are you trying to collect? What are you trying to evaluate about your car when you're driving the car this time out? And that could be anything like, okay, we've now stiffened the front anti-roll bar. So now we're going to do a skid pad run. Okay, so you do a mock skid pad, get your time, maybe you measure your tire temperatures, you take some other data off your data acquisition system or your stopwatch, whatever it is. Okay, now you make another change. Note it in your log. Okay, keep a running list of your changes. Now the driver goes out, tries this with another anti-roll bar setting, collect the data. Every single time you want to have a specific goal, you want to know what the goal is, you want to be tracking the results so you can learn from it. Make sure you know also who is doing what, because one person's driving, obviously, but everyone else on the team should be doing something useful too. So some people should be doing just make sure the data is being collected properly. Some should be reviewing the data on the fly if you have enough people to decide what the next thing is, or you may have to pause a little bit between your test sessions to decide what the next thing is. Basic maintenance, someone should be looking out for basic nut and bolt check in between runs. Those kinds of things to make sure your reliability is not going to suffer because no one was looking at it. We talked about having a setup sheet being important for a baseline. When you test, as engineers, we like to decouple everything and just focus on one thing at a time. Change just that front anti-roll bar stiffness and test that. Unfortunately, we don't have control over everything. If you're running that skid pad that you set up, throughout the time that you're there, the weather is changing. The sun has been shining on it, or the clouds came over. You've been putting rubber down on your skid pad. If you're at a fine enough level, those things matter and will start to skew your results. Your tires are wearing. If you haven't been tracking your tire pressures, as they got warmer, the pressure inside has been going up. There's all sorts of things that can change. We want to eliminate as many of those as possible. And it's always useful to go back to that baseline you started with somewhere at the end of your testing day and rerun it, and just to see how repeatable that original baseline was. Do you get the same answer back that you got when you started testing that day? And if you're trying to compare across days, that's much harder. because now you have many more things that could have changed with your vehicle, with the place you're testing. That gets much more difficult, so baselines become very important. Part of having a test plan is not just making things up on the fly, saying, oh, well, okay, front-end rail bar did this, what should we do next? Go ahead and go in there with a test plan, and it can have a few different branches on it, depending on what you learn, but you don't want to waste time or energy, resources, trying to decide what is the next thing to do. And then, of course, once you've collected this data, whether it's just a plain old stopwatch or driver feedback, what have you, you have to have some way to evaluate it. Okay, data's nice, but until you interpret it, it's just a bunch of data. Okay, it's really not anything useful engineering until you pull the engineering information out of it. So make sure that you have a way, or you're thinking about ways that you can interpret the data you get. And what you'll find is that as you start doing this, you'll start to think of more ways to interpret the data, and you'll just grow and learn as you go, which is wonderful. Okay, as far as the data organization goes, one of the things that we are always disturbed by with these data acquisition systems is when we ask the students now, okay, you've got this many channel data acquisition system, what do you do with it? And sometimes the answer back is, well, we look at the speed trace. And it's like, okay, what else do you do with it? Well, we look at the speed trace. It's like, okay, so it's nice that you have a data acquisition system, but now you've got to actually do something with it, okay? Make it work for you. And to do that, you need some kind of way to organize your data across different testing sessions, having it line up with your vehicle settings, have notes as to what you learned from all that. It's got to all come together, or else it's just going to be a bunch of data and numbers, and it will be underwhelming. And then, of course, once you get back from testing, it is good to kind of wrap it all up, tie it all together, sit down, think about how it went, not only just your process of how you went testing and what could we have done better and what went really well. We want to keep doing that. Also then look at the data. What did you learn? How are we going to use this now to influence the vehicle design, or to, what are we going to make a permanent part of our setup, permanent in quotes, but that's like in for now. What are we going to keep looking at next time? What's the next target? So these are all the kinds of things we want to look at from an engineering side of testing. And of course, that doesn't take away at all from the, wow, this is just so cool. We get to drive a car, and that's our car, and I built that, and it's, that's always a part of it. It doesn't matter how far you are away from your Formula SAE days. The opposite end of the spectrum from what you were thinking when you first saw a Formula SAE car, for most of you, I trust, was not, wow, look at that, it's a Formula SAE car. I can't wait to read the documentation. Right? I doubt that you did that. Maybe a few of you, that's okay, but most people don't have that reaction. So the truth is that you never get away from documentation either in your career. That follows you as long as you go. It's very important to be able to convey information engineer to engineer through specification sheets, through charts, through graphs, through efficient slides, through drawings. This is a language that we use as engineers to talk to each other. And the documents that you're required to submit exercise all of those different elements. Now, this is actually a really important slide, because if you think about it, we talked to you for the very first time 2 days ago. And we talked to you for 45 minutes. And if you're a finals team, we talked to you for a little bit longer, but most teams we talked to for 45 minutes. The design event did not start 2 days ago. Okay, the design event actually started with the submission of these documents, which was like 7-8 weeks ago. Okay, so for most of the time that we've known you through your documentation. Okay, one of the questions that we get sometimes is, or a complaint is, oh, that judge, he had a preconceived notion about us. He thought this, this, and this, and then if we ask the judge, he's like, well, yeah, I read the report. I thought that because I read the report. That's what it said, so I started there. Okay, so we do have some kind of an idea of what you're doing, who you are, and where we want to start from in evaluating or asking about what you did based on your documentation. So this is your car's and your team's resume. This is your first impression. It's all rather important that way. I guess one of the things that you definitely want to do for all three of these documents is to make sure you follow the template and the rules. Okay, it sounds simple, but you really want to do that, because if the first impression you make is that, oh, we didn't follow the rules, we didn't follow the template, you're in a very small minority, and you set yourself apart in a not so very good way. So it's really in your best interest to start off on the right foot. Not that you can't recover from that, but it just helps, right? I mean, you want to get the ball rolling in a good direction from the start. With the design briefing, keep in mind that this is written for engineers. Okay, so this is really technical document. It doesn't have to be marketing. It doesn't have to be written at a level that anyone can understand. It really is written for engineers who know their stuff and will understand what you're talking about. It provides an overview of your work, as we said. It is important to be concise. Size does not equal goodness. Okay, so just like when you're talking about designing, making it look easy is hard. That's really at the crux of engineering, right? It's getting it down to its minimum that does the job that it needs to do, and that works with design briefings and documentation as well. One of the important parts of the design briefing also is, in the template, we ask you for a little bit of an introduction to your team, a little bit of a history, and we really want to know, where are you coming from? And this is your opportunity to tell us, okay, well, we're a team that gelled, 3 years ago. We had a core group together all this time. We finished, 30th 2 years ago and 20th last year, and we're going for top 10 this year. Okay, this is your foundation. And we also would like to know if you're a team that, last year everybody that was the core member graduated. We're a bunch of sophomores, and we have this project, and we're picking up the pieces. They didn't do a great job of knowledge transfer, and that's important for us to know too. We want to understand where you're coming from, as much as just the hard engineering goals and such, because they do go together. The development of these Formula SAE cars is necessarily an evolutionary process. Where you start, for better or worse, is where the last year's team left you, right? And we want to know that and have that context when we evaluate your design and your team. Okay, as far as the design spec sheet goes, okay, again, follow the template, please. The template has units in it already. Please use those units. One way to set yourself apart in a not so good way is to use other units in the template while it still says this particular units. And it was mentioned earlier, but be accurate as you can. We understand you haven't finished building the car when this is submitted sometimes. Tony mentioned the variations that you could have for good reasons between the spec sheet and what we actually see when you're here. But you really want to be as accurate as you can, and there is no reason to not be accurate across all three documents. It's always disheartening when we see a team that says their car weighs 400 pounds in the spec sheet, and in the design briefing it weighs 430, and then you put the weight of the car in the three-view drawing, and there it's 390. And it's like, they were all due the same day. How is your car 3 different weights? Okay, so these are the kinds of inconsistencies that can happen in these documents, which really it's just another way to set yourself apart in a not so good way. As engineers, we have to be good at crossing the T's, dotting the I's, having things tidy, all pulled together, and that's just part of it. As far as the three-view drawings go, once again, follow the rules. That's probably the most important thing you could do. The rules want 3 views, 1 per page, and they are line drawings. Okay, these are not solid model renderings. These are actually proper engineering line drawings, preferably with a title block, with a reference frame, with your cutouts properly referenced, with a scale, with a paper size. We've had the 3-view drawing judging here for many years, which has been separately judged from the design event. The goal has been to increase the quality of these 3-view drawings. It's been largely successful. If you didn't see them, the top 10 drawings, which are not the same as the top 10 teams in the design event, but the top 10 drawings were posted in G2 throughout the event. There might be a couple still up there. If it's your team that was up there, you're welcome to take the drawing home with you. But we put them up specifically to say, hey, here's how you do a good drawing. Okay, it's as a good example. And I'll just make one note. If you read the rules carefully, it does say that we are allowed to score the design documents. To this point, we have not. That does not mean that in the future we will continue not to do it. That is entirely out there as a possibility. So we're not saying it's going to happen. We're not saying it's not going to happen, but just a reminder that the rules do allow that for us to do. And with that, we've come to the end of the planned portion of this. If you have any questions or comments, we will field them and answer them best we can. Thank you, everybody. Okay. All right, so who has a question? You have a question? Okay, so the question is, if you're a team that doesn't have a whole bunch of resources, a whole bunch of time, it's going to be hard to do a whole bunch of testing, what do you prefer goes into the design binder that you bring to us at the design event? Is that correct? Okay, do you want to? You'll take it?
Oh, good. I'll try to think of something else.
I think the first thing I would challenge is how much resources do you need to get good data? I think quite small. Maybe the scope is different. So if you get a fish scale and you pull on your upright, you could measure some compliance. You could, obviously lap times are a source of data. You just need the stopwatch. So I would say think about everything you're doing and all of the design work and how you could validate it in the simplest way possible. So it's really not about fancy data access systems. It's like from the component level all the way to the full vehicle level, you can get data along the way to inform your design. Does that make sense? Next question. Yeah. I think the question was, is there a way to get feedback on the documents you submitted, perhaps besides the 3-view drawing? So I would say yes, you can talk to the judges who you had in your queue to get that feedback. They all have reviewed the documents ahead of time. Right now it's a bit too late. But in the future years, be sure to ask them about it and get feedback. Any other questions? Really, there's anything design related is okay. Yeah. Actually, it's getting live streamed right now to YouTube, and you can watch the video on YouTube later, and you'll be able to see the slides through the video. The link is in the app if you have the app on your phone. Also, I've successfully searched for it in the past and found it relatively easily.
But don't look for your old ones.
Yes.
I know, I was just...
So for knowledge transfer, I'll speak to what we used to do. You guys can feel free to chime in. But I think it was one of the things that for the few years that I thought we were successful, it was really important, which was everybody wrote sort of a technical paper and a personal paper. So we did that both at the at the end of first half of the year and then at the end of the full year. So for example, when I was competing, I was doing chassis, and at the halfway point, I'd write a report about, okay, this is what the chassis is trying to do this year. This is the goal of it. We also did design reviews. So actually, if you use the template we gave you for design and ran design reviews as a full team, I think that would set you up for a lot of success, not just from a design judging later, but also for driving good outcomes along the way. So those are kind of the two steps there. And then I should say as well, at the end of the year, we wrote a final report that said, hey, halfway through I thought the chassis was going to do this or the drivetrain was going to be like this, but it changed. I learned all these things. Here's all the sponsors I called. Here's where I got all my parts. And it was a really useful tool. So people could come in the next year, and if you weren't around, they could read your reports, look at the design reviews, and understand some of the basics. And all of those were kept on a computer in the office on a hard drive. And so to this day, you know, my former university has my old reports, which are obviously not very relevant, but they can go back and look over many years and have access to that data. So I think No matter what else you do, all of your work, save it and let people reference it later. That's sort of my tip.
And I guess I've got a couple of things. I mean, piggybacking off of the design review, if you have access to them, I highly suggest you bring back alumni to help with some of those design reviews. Odds are pretty good. Some of them graduated and left and took some of the knowledge with them. But then if they come back for a design review, you keep them engaged. Then they'll be able to say, oh wait, we did this. Did you think about this? And you'll be able to. It's a little bit maybe after the fact, maybe from like the initial design, but you will still be able to use that resource to kind of pull some of that information back in. So that's one thing. Another thing is underclassmen, getting underclassmen involved early. I know a number of universities basically have this is a senior only kind of a thing. To be honest, I kind of think that's kind of crap. And I know I'll probably have an advisor or two maybe email me to say they don't like the fact that I said that, but I do believe it. I think we should be trying to get underclassmen into the program as early as possible. It helps them, as they're taking classes to learn. There's always an application, something to apply this knowledge to, kind of a thing as they're going through classes. And if you pair a senior working on, let's say, the aero package, and you've got an underclassman kind of right there helping, kind of almost like an assistant kind of a role. They're learning how to use the tools from the senior person. They're learning, they're seeing firsthand what worked and what didn't work. So then when it comes time for to pass that baton, they've already got a head start. They're already running half speed. So then they can just take off running from that point on. Yeah. There was a third thing, I can't remember what it was now. Well, those two are kind of useful. So.
Okay, this is a really important question. So I think let's look at it from a different angle. Why is knowledge transfer hard? Why does it fail? What goes wrong? There's a couple fairly common ways this falls apart. One is that you have a team that's either rebooting or just starting out, and quite frankly, it's hard to do what you do. Right? It's hard to build a car in a year, much less design it and build it and test it and do all the things we are asking you to do. This is not easy. Okay, so if you're just starting out especially, juggling all that, it feels like an awful lot, and the idea of somehow writing this down and recording it so that someone can learn from it in the future is honestly not something that reaches the top of the priority list. And that's a common way that it falls down. So what we tend to see is teams like that can get stuck in a cycle of, we just made it to competition. Whew. Oh, we just made it to competition the next year. Oh, we just made it, and there's never this, and they keep restarting from the same point. So one of those teams has to break the cycle and say, okay, we've been just working our tails off to get there and to actually just make a car that runs and passes tech. But you got to somehow write down what you learned or pass it on to people somehow. Okay, don't get just so caught up in we just got to make it there. Another way this falls apart is if you want to take the exact opposite approach, you've got a really good team that, especially if it has a lot of senior members that have been doing this together for a few years and they've gelled and it's like their team, then they may, this goes two ways. One way is that they may not be interested, and not in a bad way, but it just, they've got a group, they work together well, and they may not be so interested in pulling in the younger members. And so there's people that keep showing up and say, hey, I'm really interested, and they're like, but you're not part of our group. And it doesn't come across that way directly, but that's the end message is, you're not in our circle, we've got a nice circle here, and what they have to do is expand their circle by the time they're in their senior year to include the younger members of the team so that when they leave, that the team continues to go in a healthy way. The opposite also happens. You get a really good team together, seniors especially that have gelled, and they realize that they started from nowhere. The previous team left them high and dry 3 years ago, and they fought for every single thing that they learned in the past 3 years. And now they don't want to put the team behind them in that same spot again. And so they're going to document everything, they're going to write it down, they're going to make videos and whatever the way they're going to transfer this knowledge, but they're going to do it, and they do it. And of course, the people behind them aren't as invested as these people were. And they want it to be their own thing. They want to learn it themselves. They want to do it themselves. They don't want to build the car that the people ahead of us built and do the things that the people ahead of us learned. So they reinvent the wheel. And so Sometimes it's actually there sitting for you as a resource, whether it's in written documentation or just like the people are still in contact, you can talk to them. You may find that the people, even if the relationship wasn't awesome when those people were a year ahead of you after they graduate, that may turn out to be a little bit better than you think. So never hesitate to reach out to previous members, and definitely don't hesitate to listen to previous members, because you really can lose a lot by reinventing things and going through experiences again that your team has already been through and don't have to relearn. So those are just like 3 of the main ways that this goes wrong and why it's hard. And some of it is just basic human nature. I know you want to do your own thing, but don't neglect what's happened ahead of you. That's a sad one for us.
Yeah, one of the sayings that we'll often hear around Formula SAE, in particular over in Formula Student, there used to be a regular presentation, kind of like this, but maybe a little bit more formal. But the saying, those who don't know their history are bound to repeat it. And we routinely see SAE teams come back time and time again, making the exact same errors. They have the same kind of design flaws or whatever. It's like, man. It's like if they just passed the knowledge on, if they had just learned from the people before them, it's like they're so close. They just need to, they just keep one step forward and then one step back, and then and I guess I just have a word of encouragement, for everybody here, you have the potential for basically being the start of like the next great Formula SAE legacy team, the great historic, I'll just say the Cornells, the UTAs, the RITs, the ETS, the teams that a lot of people, maybe I'm dating myself, with some of those, team references. But anyway, yeah. But at any rate, it's the fact of the matter is you could be the start of like the next great, SAE legacy, and I think the key thing there is to just do whatever it takes to try to pass that knowledge on to future Formula, for future Formula generations. We're ready for our next question. What you got for us? All right. Go ahead. Oh.
I'll say.
Yeah.
The question was, what's a good time? I'm going to say good, not necessarily recommended timeline for vehicle manufacture. You asked about chassis manufacture, but I think the thing that we would probably all value is we can say a date, but the date's probably way earlier than you think it is. So, for example, February 1st was sort of the date that we always used when I was competing. We wanted the vehicle running. It was a very cold climate, so we weren't getting good test data in. But what we found was any year we didn't have the car done by February 1st, we didn't do well. It didn't mean we did well when we were done on February 1st, but we had a very strong correlation between success and being done early. So I think generally we would do first design reviews around October, like Halloween was first design review, second design review around November, and then we were in strong manufacturing over Christmas break, and we were trying to have first drive in February 1st. That's a timeline. It's not the right timeline. There is not a right timeline. But get the thing done, tune, test. That's really the key.
Yeah, and I think really the discipline thing is probably the most important thing. It's easy. It's even in the professional world, it is really easy to lose a month or two, a day at a time, and you. I've got some thoughts running through my head, and I think Bill might be thinking of the same individual that's been hammering on us pretty good recently. But anyways, just you need to set a timeline. Just try to be apply as much logic as you can, and then do the very best you can to actually hit those dates. And if you can't hit the dates, you need to be thinking about what are the implications down the line going to be. You can't just let it all pile up towards the end and, well, okay, we've got 1 day left. Let's develop our car. You need to be working through some contingencies and planning for those contingencies if you feel as though you're not going to be able to hit the targets.
And what I'm going to say next, this may be the first time I'm preaching to the choir on this one, because we all know about supply chain issues. That's sort of a thing now globally. But that's not just a thing that you're going through in this one moment in time, because you will always run into issues with your suppliers. You don't know which one, but somebody's going to let you down probably along the way. Somebody's not going to meet a deadline that's out of your control. Okay, so you always have to have enough room in the schedule to accommodate that without getting yourself completely screwed over because you've ran out of time because you didn't leave enough time for other people to screw up. Okay, you can't control everything, and it's not just a new thing that's happening in 2021, 22. This is going to continue happening throughout your careers. It's actually normal. It's just like more widespread right now. Yeah.
I want to say one more thing, which is I think that in looking back, like the schedule, again, the schedule is a thing that you prescribe and you work and you hold it, much like vehicle mass, much like safety factors. You dictate safety factors and then you try to exceed them. They're not things you just get as a result. You need to manage the schedule hard to be on time and have time. That's probably the most important thing. All right, I think we're going to do our last question since we're coming up on an hour.
Someone's got to have a doozy for us. Come on.
All right, well then, if we're all done with questions, thank you so much for coming. And let's again, thank you all for coming and participating in the design.